Trigonometric equations, part 2. What we want to do is to find the points of intersection of the line, the straight line, and the trigonometric graph, which is to say these 2 points here. Now we know that the equation of the line is y equals 2. That's been given to us. What we do not know is the equation of the trigonometric function. It should be easy enough for us to work out. We know that the maximum value is 3, that the minimum value is minus 3, and that it has a period of 360 degrees. We also know that it starts at 0 and then moves up to its maximum, which tells us that it's the graph of 3 sine x. Now, to work out the points of intersection, what we have to understand is that at these 2 points, the trigonometric graph 3 sine x is equal to the straight line 2. So we can set both equations equal. What we now have here is a simple trigonometric equation which has to be solved. I'm going to divide both sides by 3. So 3 sine x then equals 2/3. We've simplified the trigonometric equation. We can now use a cast diagram. It's the sine function and it's positive. Sine is positive in A and in S. What we need to do now is to use a calculator. So x equals sine to the minus 1 of 2 divided by 3. And that gives us the value 41.8 degrees. The second value is found by subtracting the first answer from 180 degrees. So that's 138.2 degrees. Now, what I could do, if I wanted to state the coordinates of the points of intersection, well, the first point has x coordinate 41.8 degrees. And what's the y coordinate? Well, the y coordinate must be 2 because the point lies on that line. And the coordinates of the second point must be 138.2 degrees, and it also must have a y coordinate of 2. In this example, we want to solve the trigonometric equation 5 cos x minus 1 equals 3, which is simple enough to do. The important thing is that instead of having a 360 degrees here, we have 720 degrees. Well, let's see what happens. So I'm going to solve the equation as best I can. First of all, by adding 1 to both sides. Then dividing by 5. At this point, I should always draw on a cast diagram. Now, the cosine function is positive because there is no negative to be seen. Cos is positive in the first quadrant and in the fourth quadrant. X equals cos to the minus 1 of 4/5, which equals 36.9 degrees. That's the first answer. The second answer is found by subtracting that answer from 360 degrees, and that gives us 323.1 degrees. Now, these are the answers which lie between 0 and 360 degrees. What on earth do we do to find the answers that lie between 0 and 720 degrees? What I've done here is drawn a graph of the cosine function showing two cycles drawn between 0 and 720 degrees. If I want to, let me just mark on any point in the diagram. There's a point here. If I want to get to the same point in the second cycle, which is to say this point here, then I add 360 degrees. If I want to get to this point here, to the same point on the second cycle, I do exactly the same. I add 360 degrees. So if I want to get the two solutions to this equation, which lie between 360 and 720 degrees, what I'm going to have to do is to add 360 degrees to both of the answers. So 36.9 degrees plus 360 degrees equals 396.9 degrees, and 323.1 degrees plus 360 degrees, which gives me the value 683.1 degrees. And in this case, we have 4 answers.